Hi, we're Group 3.
Our project is to find the challenges associated with a nuclear-propelled rocket.
Our goal is to propel a nuclear rocket to Mars and back.
However, there are many problems associated with attempting this goal.
So this project will introduce you to the 5 challenges.
So why do we pick space propulsion as a topic? Well, nuclear energy provides new and interesting things that current propulsion methods just can't compete with. To sort of reiterate what people before me said, the potential associated with a high energy, high thrust, high efficiency nuclear propelled rocket make it able to travel much further than a chemical rocket, for example. This, if harnessed, would open doorways for deep space exploration that are only possible through nuclear propulsion. Though there are many issues and challenges associated with this, hopefully we can overcome this and continue research on such a topic.
Considering nuclear-propelled rockets, there are several advantages to the conventional methods. The conventional methods for propelling rockets are chemical and ion thrusters. Nuclear propulsion offers advantages in efficiency and thrust, whereas chemical rockets offer high thrust at the cost of efficiency, but ion thrusters exert little thrust with high efficiency. Nuclear propulsion has both high efficiency and high thrust. There are two types of nuclear propelled rockets. There are nuclear thermal rockets and nuclear pulse rockets. In considering nuclear thermal rockets, it operates by using a nuclear reactor to heat up some propellant such as liquid hydrogen and then blasting it out the bottom of the rocket. The pulse rockets operate by having a nuclear blast behind the rocket, propelling it forward by the force of the blast. And then energy. Okay. The similarities between these two are that both of them operate using a nuclear chain reaction, which has a much higher energy yield and energy density compared to thermal reaction.
One major problem associated with powering a nuclear rocket to Mars and back is radioactive exposure. There's 3 types of radioactive exposure: exposure on takeoff, exposure on re-entry, and exposure during the trip. There's a high probability of radioactive exposure on takeoff and re-entry because the rocket has to go through the Earth's atmosphere, which causes a lot of friction on the rocket. So there's a higher probability of malfunction. Radioactive exposure during the trip isn't such a high risk because there's barely any forces acting on the rocket. And also, there's less nuclear output because of minimal gravitational influences. Furthermore, the environment isn't exposed, which is a major issue in today's society.
Another grand challenge of creating a nuclear-propelled rocket is the controversy it causes within the U.S. There are 3 controversies. The first part is the environmental impacts of such a project. As already previously stated, there's a higher risk of nuclear fallout during re-entry and takeoff. This can create huge negative environmental impacts. Environmental impacts are very controversial in the U.S. and we don't want to harm the environment. Second is the military ramifications of such projects. The technology that would be used in a nuclear-propelled rocket could somehow be converted into a nuclear weapon. And finally, creating a nuclear-propelled rocket would be very, very expensive, costing billions of dollars for the U.S. And getting this type of funding from Congress proves to be very difficult.
Another problem we have with the project is human aspect, because nuclear rockets produce so much more energy, more force is imposed on a rocket that the human body might not be able to withstand the acceleration in space. And that can also lead to health issues because prolonged exposure to a nuclear reactor for 3 months there and 3 months back would be good for your health. An advanced training. Say something went wrong on Mars, we would need advanced training to be able to fix the nuclear reactor.
The next element having a nuclear rocket to Mars and back is the cost. First off, there's the cost of building a rocket, and there's the cost of the materials and electronics to build a rocket generally, but in this case we have to pay for a nuclear reactor and also fuel. And this makes a nuclear rocket a lot more expensive than a chemical rocket. And the next problem is finding materials to experience nuclear exposure, because normally materials are too brittle when they're exposed to radioactive when they're exposed to radiation. And so we'd have to find fresh materials that would be willing to sustain this. And the last problem is financial problem for financial programs. In addition to the rocket, we'd also have to find astronauts and we'd have to train them. And so we'd have to pay for that. And then also we would have to pay for research to make sure that everything is safe and all of that. And so considering how expensive this would be, it's nearly impossible that Congress would actually approve to provide funding for this project. So we'd have to find private investors that would pay for the entire program. And that was our project on nuclear propulsion rockets. As you can see, this project has many grand challenges such as radioactive exposure, cost, its human aspects, and its controversies. So although this would be a really awesome project that we're all interested in, you can see there are some grand challenges we would have to first overcome.